Okay, so let's talk about this next problem. That next problem we just read was about a coroner arriving at the scene of a murder, right? Okay, so she's clearly looking at a body, and the body is cooling. So yeah, it's the Newton's law of cooling problem because it's cooling down. So we need to write that formula. The ending temperature at time t, whatever that is. Whoops, that's supposed to be a plus sign. Sorry about that. Okay, so remember, in order to work this problem out, we need to know three things. We need to know the initial temperature, we need to know the atmosphere temperature, and we need to know the rate. Can you guess which one they didn't give me? Yeah, pretty much we can guess without even delving into it too much. But let's go. Let's see what they've given us. So we have the coroner who arrives at a murder at 9 p.m. She finds the temperature of the body to be 84.2 degrees Fahrenheit. Okay, so that's the initial temperature, isn't it? So we have 84.2 degrees Fahrenheit. That's the initial temperature of the body. Agreed? Okay. And she waits 1 hour and takes the temperature again and finds it to be at 80.4 degrees Fahrenheit. And she notes the room temperature is 70 degrees. Got it. So my room temperature is 70 degrees Fahrenheit. By the way, gratefully, this is all in Fahrenheit. Because if they give one of them in Celsius, we're going to have to convert. But gratefully, they didn't do that. And basically, she wants to know, when did the murder occur? Well, you know what they didn't give me? Yeah, they didn't give me the rate, which we kind of figured they wouldn't. But we do know, right, that after 1 hour, that the temperature was 80.4 degrees Fahrenheit. Which means we can start filling in this formula in order to find, in order to find the K. And let me make this plus sign a little more obvious for us. Okay, here we go. I know the ending temperature after an hour. So we have 80.4 is equal to the atmosphere temperature of 70 plus the initial temperature in parentheses of 84.2 minus that surrounding temperature, e to the kt. Well, t is 1 hour, so 1k. All right, I'm going to simplify inside that parenthesis. Time to start moving things over. I need that k by itself, so we subtract that 70 from both sides. Agreed? We divide both sides by that 14.2, and I'm going to take this up over here. And you know as well as I do what we're going to have to do. Yeah, we're going to have to take the natural log of both sides, which tells me that k is equal to the natural log of this lovely fraction. Good? All right. Now, you can go ahead and punch that into the calculator to make sure it's a negative, because since we're talking about the law of cooling, my rate better be negative. But again, we can't round until the end. Sounds like a broken record, but you can't round until the end. All right. Now, I am going to fill in my pieces of the puzzle up here to write my specific formula. I know the temperature of the surrounding was, or is, I should say, 70 degrees. I figured out this parenthesis to be 14.2, so I'm going to write it as 14.2, just to make it a little bit simpler. And times e to the kt. T is what I don't know, but I know my k is the natural log of this fraction. Good? And now they want to know, well, when did this murder occur? How long? So you're looking for time, aren't you? Okay, so here's the deal. How long ago was in the past? So in the past, right, when the murder occurred, the temperature of the body in Fahrenheit is 98.6, isn't it? And if you're like, I don't remember, well, go look it up. But the normal temperature of a body, of a human, is 98.6 degrees. So technically, at time 0, because the murder hadn't occurred yet, so I kind of need you to think of it this way. So basically, at time being equal to 0 hours, this was before the murder, the temperature of the body was 98.6 degrees Fahrenheit, wasn't it? So, over here, I am going to start filling that in. So at 98.6 degrees is what the ending temperature of the body was before it was murdered. And now I'm going to look for how long ago I'm trying to find how long ago the body's temperature was at 98.6 degrees. Because when I know how long ago it was actually at the normal temperature, I'll know when the murder happened. Does that make sense? If I can figure out how long ago the body was at 98.6, how many hours ago? Cool? All right, so let's start doing some of our work here. Minusing that 70 on both sides, right? You're going to have to divide both sides by the 14.2. Agreed? And you know as well as I do, you're going to have to take to get rid of that E, you're going to have to take the natural log of both sides, aren't you? Okay, so I'm going to have to take the natural log of this lovely fraction. And you can tell what you're going to have to do to get that t by itself, aren't you? Yeah, you're going to have to divide both sides by this ln, right? You're going to have to divide both sides by that natural log. And when you do that, you end up with t being approximately negative 2.25 hours, which means the murder occurred 2¼ hours ago. So if she got on the scene and it was 9 p.m. and according to the calculations, the murder happened 2¼ hours ago, then they're approximating the time of death at, that's right, 6:45 p.m. You with me? Kind of cool, huh? It's an everyday life problem, not for us, but for those people who are in forensics, the medical examiners. They go through this stuff. And yeah, I'm sure they have it programmed into a computer, but still they kind of have to know how things work. They need to know what they need, right? Cool. I got one more problem for us. And no, it's not a cooling problem.